Alright, this is Chapter 2, Lesson 6 on ratios and proportions. Ratios allow us to compare basically two items with two different units, and then proportions allow us to compare two different ratios. As you can see, we have a lot of new vocabulary, so we'll go over that throughout the chapter, and we'll talk about the various ways to solve proportions. Actually, the way to solve proportions. There are not really various ways to solve proportions. Alright, so let's start with the definition of a ratio. A ratio is a comparison of two numbers. And that's using division. Okay, ratios can be written in three ways. Right, so we can write x to y. We can write x to y with a colon. Or we can write x to y as a fraction. These are all the same thing. They all say the same thing. But for every whatever number this is, there's this many of this number. So for example, I can say 2 to 3, which can be written like this. So for every 2 of this, there's 3 of those, basically is what that's saying. Right, so we want to look at some examples of, like a hard example of ratios. So the example in the book gives us the number of restaurants per 100,000 people. And this is in Australia. And they give us the original restaurant that there are 0.349 restaurants for every 10,000 people. And then we don't really like to have decimals in our ratios, so they multiply both the top and the bottom, by 10. So they are still leaving decimals in there, even though that's not really normally what we do. So there's 3.49 restaurants for every 100,000 people. Okay. Now, these two ratios are equal to each other, and so they make up a proportion. And proportion is a comparison or equation stating that two ratios are equal. And sometimes we have to determine if this is true or not. And so the way we do that is we are going to cross multiply. So so again, a proportion is when two ratios are equal. So we want to say, there's two ways to do this, okay? Method 1 and method 2. Okay, method 1 is to simplify each ratio, then see if they're equal. And method 2 is to see if the cross products are equal. you can do either method. We're going to start with simplifying. So we'll start with method 1, and then we'll go to method 2 in a moment. So we're going to see if the following ratios make up a proportion. So 2/3 and 16/24 are the first two examples. And so 2/3 is already simplified. 16/24, however, these are both even, so I can divide by 2. And yes, I could divide by a larger number, but we're going to start by dividing by 2 in case you don't see the larger number. And they're still even, so I'm going to divide by 2 again. And I'm going to get 4/6, which is still even, so I'm going to divide by 2 again. And I finally get 2/3 and 2/3, and 2/3 are equal, so yes, they form a proportion. Okay, let's try a couple more. 6/10 and 2/5. Well, 2/5 is already simplified, so we need to reduce 6/10, which again, they're both equal, so I can divide by 2. And when I divide by 2, I get 3/5. 3/5 and 2/5 are not equal, so they are not a proportion. Let's try another one. 1/6 and 5/30. Again, 1/6 is already reduced, so I just need to reduce 5/30 and see if it's equal. These both divide by 5. That's a really weird looking 5, but it's a 5. And I get 1/6, so yes, they form a proportion. Okay, let's try another. We're going to get to method 2 now. Now we have in a proportion. Okay, if I write my proportion in this method, like this, using this method, the numbers in the center, those are the means, and the numbers on the outside are the extremes. And it's easy to remember which is which because the outside is like the very furthest out, so they're the two extreme points. And the means are in the middle. Middle starts with M. Now, if we write a proportion in another way, so in our fractional way, the bottom of the first proportion and the top of the second are the means. And then the top of the first proportion and the bottom of the second are the extremes. Okay, so again, the extremes are the top and the bottom on the farthest sides. Now we have a theory in math that tells us if the product of the means is equal to the product of the extremes, then the ratios form a proportion. Okay, so if I have just some random numbers, what I'm going to get is AD, and multiply my extremes, is equal to BC. Okay, and this is called, this is actually called the means extremes property. Of proportions. But a lot of people also call it the cross product property, because that's a little bit easier to remember because you're making cross products. So let's look at our example from just a moment ago. I had 2 over 5 and 10 over 25, and now I want to know if this is true. Well, I cross multiply, and I get 5 times 10 and 2 times 25, and that's 50 and 50, so they are equal, so yes, they are a proportion. This was method 2 of how to determine if two ratios form a proportion. We use the cross products. So let's look at some examples of that. I have 2 and 3.5 and 8 and 14. And I want to know, are they equal? So what I'm going to do is I'll rewrite them. I will cross multiply, which will give me 2 times 14 and 3.5 times 8. And 2 times 14 is 28, and 3.5 times 8 is also 28. So they are equal, so yes, they are a proportion. So example B. I have 0.3 over 1.5, and I want to know if that is equal to 0.5 over 2.0. And you can see sometimes reducing is a really easy way because you can see it easily, but with decimals and things, cross products makes determining if these are proportional or not a lot easier. So I'll have 0.3 times 2.0 and 1.5 times 0.5, and I get 0.6 and 0.75, and these are not equal, so they are not a proportion. Let's look at a couple more. 0.2 over 1.8, and we want to know if that is equal to 1 over 0.9. I'll cross multiply, so 0.2 times 0.9 and 1 times 1.8. I get 0.18 and 1.8. These are not equal. They are not a proportion. Last example, 15 over 36 and 35 over 42. Cross multiply. 15 times 42 and 36 times 35. 15 times 42 is 630. 36 times 35 is 1,260, which are very much not equal, so we are not having a proportion. Can't spell, oh my goodness. Right, sometimes we're asked to solve a proportion rather than just determine if two ratios make a proportion. And so when we solve the proportion, we use cross products. So let's look at an example. X over 10 is equal to 3 over 5. Now you might see the scale of this, and we'll talk about scale in a moment, but you might quickly see that 10 is twice 5, and so you might see that x should be twice 3 and x should be 6. But if you don't see that, because sometimes the proportions aren't so easy to see, we go ahead and we cross multiply. So 5 times x is equal to 3 times 10. So 5x is equal to 30. Divide both sides by 5, and you get that x equals 6. And even if you think you see it, I recommend going ahead and cross multiplying just to double check yourself. Okay, let's try another example. X minus 2 over 14 is equal to 2 over 7. Now when this occurs, we still cross multiply, but instead of just multiplying 7 times x, I have to multiply 7 times x minus 2 and 2 times 14. So I will need to distribute this 7, giving me 7x minus 14 is equal to 28. I will add 14 to both sides, giving me that 7x is equal to 42. I will divide by 7, and I will get that x equals 6. And x does not always equal 6, that's just some weird fluke. Alright, let's do 2 more. I have r over 8 is equal to 25 over 40, and x plus 4 over 5 is equal to 3 over 8. And actually something that you might try is to go ahead and pause the video and try to solve these on your own, and then check your work by turning the video back on and seeing if you got it right. An idea anyway. Right, so we're going to cross multiply. If you're going to pause, do it now. And I get 40r is equal to 8 times 25. So 40r is equal to 200. Divide both sides by 40. And r is going to be equal to 5. Here I have some addition again, so when I cross multiply I have to remember to distribute. And I get 8 times x plus 4 is equal to 5 times 3. So 8x, again, don't forget to distribute. 8x plus 32 is equal to 15. Subtract 32 from both sides. 8x is equal to 17. Divide both sides by 8. And x is equal to 17/8. And if that really bothers you, you can go ahead and put that in decimal format. But leaving it as a fraction is perfectly fine. Alright, so let's talk about scale. Or sorry, no, rates and unit rates, okay? So ratio with 2 units, or 2 measurements, sorry. 2 measurements having different units is called a rate. And you actually are very familiar with rates. We see these all the time. If you go grocery shopping, let's just say we can get 5 pounds of apples for $4.99. So I have pounds and dollars, 2 different units. And this is the rate. Every 5 pounds costs $4.99. Now, you're probably most familiar with what's called a unit rate. And a unit rate occurs It's a rate that tells us how many of one item, one, is being compared to one of another item. You are probably most familiar with this, miles per hour. There's some number of miles per 1 hour. So 55 miles over 1 hour. If we go back to, say, a grocery example, when we talk about buying in bulk items, it'll be like, say, for example, grapes. You could get grapes that cost $3.99 per 1 pound of grapes. Okay, and these are unit rates. Your denominator basically will always be 1. So let's look at an example, and this is a word problem, so I am going to write this down really quickly. So our example is, in the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer open in the next 3 years? Okay, so our ratio is 232 stores over 2 years. And we want to know how many stores in the next 3 years. Now there are 2 ways we can solve this. We can solve this with a proportion, or we can solve this with unit rates. Okay, solving this with a proportion, we set these 2 equal to each other. And I call the number of stores x because I don't know that. And then I cross multiply, and I have 2x is equal to 232 times 3. So 2x is equal to 696. And I divide by 2. And I have that there will be 348 stores in the next 3 years. Now, using a unit rate, I have 232 stores over 2 years, and I want my denominator to equal 1, so I divide by 2. I'm always trying to make that denominator equal to 1. Okay, so since I've divided both by 2, I get that there were 116 stores per year. And I want to know over 3 years, and so I get 348 stores in 3 years. So these are just 2 different ways of working out the same problem. They're both correct. You can use either method. Okay, let's do another example. So I'm going to write it down. All right, so it takes 7 minutes for Isabella to walk around the gym track twice. At this rate, how many times can Isabella walk around the track in half an hour? Okay, so half an hour is 30 minutes. And we want to know if every 7 minutes she can walk around it twice. I want to know in 30 minutes how many laps. So I can do this with the proportion, or I can do this with the unit rate. So I'll solve the proportion first. I'll cross multiply, and I get 7x is equal to 2 times 30. So 7x is equal to 60. Divide by 7. And x is going to equal 8.5 times, so 8.5 laps. It's actually 8.5714, but I'm just going to call it 8.5. Now, using a unit rate, again, I want my denominator to equal 1. So I have to divide by 2. So I get 3.5 minutes for every 1 lap. Okay, and we want to know how many laps she can walk in 30 minutes. So I have to take 30 minutes and divide it by 3.5 minutes. And that will give me the same 8.5 laps. All right, one more concept, which is scale. This is used when we make models. Why did I write the number 2 there? Okay, now I know that you guys have all heard the term scale model, and we use scale to make a scale model, and we use scale when we're drawing photos or pictures. Like, for example, if I wanted to draw up a blueprint, obviously if I'm drawing the blueprint of a building, I'm not going to make it the same size as the building. I use scale to make a smaller version. Or if I want to draw a picture of a virus, or make a computer projection of a virus, I use scale because an actual virus is microscopic and that's too small, so I want to make it larger. So scale is used when we model something that is too large or too small. Now, a scale model is an actual 3-dimensional representation of an item. Okay, and this word here, proportionally, scale is a proportion. So we make something half the size, or 1/100th of the size, or 50 times the size. And then scale models are models that are made by using scale. So we either, for example, if I wanted to make a model of a virus or a bacterium, I would scale it up in size, I would increase it. And if I wanted to make a scale model of a building, which I'm sure you guys have seen those in movies or TV where they're presenting their design to some company or whatever, and they bring in like a little model of the house or the city. So they've reduced it proportionally. So that's the key word though, proportionally. That's the important word right there, proportional. Scale models are proportional to their actual item. So let's use an example using scale. Okay, so this has to do with maps. The scale on a map of the Great Smoky Mountains National Park is 3 inches equals 10 miles, and the length of the Ramsey Cascades Trail is about 1 1/8 inches. So we want to know what the actual length of the trail is, and this is, you see this on the side of a map, the scale, and it tells you how many inches equals how many miles. So on this particular map, 3 inches is 10 miles. And we want to know how many miles 1 1/8 inches are. So I'm going to cross multiply. And before I cross multiply, I'm actually going to convert this into a decimal. So 1 1/8, I divide 1 by 8, and I get 0.125. So this is 1.125. So 3 times x is 3x, and 10 times 1.125 is 11.25. I divide both sides by 3, and I get that x is equal to 3.75 miles. So that trail is 3.75 miles long. All right, let's try one more example. Okay, you've all seen model building kits. I'm sure that people can build model airplanes, model cars, model trains, and the model airplanes and model cars are to scale. They're a scaled down model. And so on this particular model airplane, the scale is 5 centimeters is equal to 2 meters. And if the wingspan of the model is 28.5 centimeters, what is the actual wingspan? So first we need to set up a proportion. 5 centimeters is 2 meters, and on the model we have 28.5 centimeters, and we don't know how many meters. So we cross multiply, and I get that 5x is equal to 2 times 28.5 is 57. I divide both sides by 5. And x is equal to 11.4 meters. Okay, and now we'll go on to the note-taking portion, and that is the end of Lesson 6. Okay, Chapter 2, Lesson 6, note-taking on ratios and proportions. We're going to compare ratios. And then we are going to solve proportions. Okay, so let's move on to the vocabulary, and there's a lot of vocabulary here. We're going to fill in each blank with the correct term. Let's see if I can zoom out a little. Just that strong direction. Okay. In the proportion 2 to 5 is equal to 6 to 15, numbers 5 and 6 are known as we have unit, ratio, mean, rate, model, extreme, proportion, and scale. They're known as the means. A blank is an equation stating that two ratios are equal. That is a proportion. A blank is a rate used when making a model of something that is too large or too small to be convenient at actual size. That is a scale. The comparison of two numbers by division is known as a ratio. A blank rate tells us how many of one item is being compared to one of another item. That is a unit rate. The proportion 1 to 15 is equal 3 to 45. The numbers 1 and 45 are known as the extremes. The ratio of two measurements having different units of measure is called a rate. And a scale model is a three-dimensional reproduction of an item that has been reduced in size proportionally. Okay, we're going to use cross products to determine whether the pair of ratios forms a proportion. So I have 3 over 4 and 4.2 over 6. And I'm going to cross multiply. And so I will have 3 times 6 and 4 times 4.2. 3 times 6 is 18. 4 times 4.2 is 16.8. These two things are not equal, so not a proportion. Right, and then we have a graphic organizer. Alright, we have a women's franchise opened 336 gyms during the past 3 years, and we want to know how many gyms will they have opened after 5 years. So I'm going to put 336 here, and I'm going to put X here. To solve this, I'm going to cross multiply, which is going to give me 3x is equal to 336 times 5, which is 1680. I'm going to divide both sides by 3. And then I will get that x is equal to 560 gyms. And this is the same question from our last note-taking. So I am assuming that they made a mistake there, but I'm just going to say plug in and check, which is what we said last time. So sorry about that. I don't know what happened there. And that is the end of the note-taking for Chapter 2, Lesson 6.